this is me. I work at Engine Yard. It's my personal plug website. I'm not sure why I put that there. That's me on Twitter. You could find me on the internet as Shai Guitar. And I'm going to start by reading this tweet that I liked a lot. So not having an API in 2012 is like not having a website in 1998. And the reason that I like this tweet a lot is because I really think it summarizes where we are in the industry right now. Is, you know, if kind of last bubble we were all about having the web and websites and putting your bar on the web or whatever, now it's all about software as a service, infrastructure as a service, platform as a service. I even had a roommate who had razors as a service. And the whole point of as a service is really to have your product have an API that customers can actually interact with, right? And so I'm going to be talking about how we test these APIs that we build. So the specifically problem statement I'm going to be talking about is testing the server and client API. And I'm going to be talking about testing the server and client that we build in conjunction together. So this talk actually came out of work done in a very large distributed system where different systems need to talk to each other, and they talk to each other through APIs. And so we're going to have each system talking to each other with an API that it exposes and a specific client that will consume that API, and the other system is going to use that client to talk to the other system, right? And I have this guitar, and you may be wondering why I'm telling you that I have this guitar, but it's because I want to set the context for this talk. I'm going to be talking about a music labeling company, and so I want to set the context. When I say we, I mean this music labeling company, right? And so I'm going to introduce the characters really quick. We're going to have a server developer who likes coffee. We're going to have a client library developer who does a lot of work, you'll see. And we're going to have an app developer consuming that client library, and that's going to be basically, he's not going to be part of the company, he's going to be a musician on the side that's going to be trying to consume that client library that's going to consume our API, right? And so we're going to have an API that's going to expose a pretty simple API. Our domain model is going to be a title and is going to have a name and words. And we're going to make sure that the name or title is going to be unique, right? And we're going to expose a post. We're going to post a song. We're going to post a title and a name and words. And we're going to get that title and get the words back, right? And yeah, so we're going to build a client for that API that consumers will be able to. Hold on one second. I think I missed slides. Right. So our goal is to create these endpoints in the server. Right? And we want to build a client, and that client's going to look like this with this interface where we're going to have that post song and get song method. And those two methods in the client are going to be actually talking to that server in the back end, right? That post and get method. And so when we post a song, we're going to post a specific title and then the words. And then when we get the song, according to the title, we'll get the words that we just posted to that song, right? And I want to make it easy for consumer applications that use that client library to test with it. So just a quick show of hands here. Who here has used Fog or knows about Fog? Any chance? That's awesome. So who here actually has interacted with the mocking system that Fog provides? Not quite as many. But what it basically has, there's other client gems that have this, like Zendesk 2, which basically allow you to interact with the client in a kind of a test mode, which is basically this mock mode. You do client.mock, and you can interact with what's going on in the client, and you'll get back the behavior of the server even though you're not actually making any real requests, right? And so I'm going to touch back to that later in the talk. So I'm just going to reiterate the plans. We are going to create an API musicians can use to store songs with a name and a title and a unique name. We're going to build a client library that can be used in consumer applications, and we're going to make it easy for consumer applications to test with that client library that we just created, right? And these are the characters that I'm going to touch back into in this talk. All right, so how do we test APIs? So small caveat, these are all terms that I made up. Isolated approach, the sandbox approach, fake servers, and mappers. I'm going to explain these approaches that I've come across when developing APIs and such. And there's obviously probably a lot more. These are the ones that I'm going to touch into. So I'm going to start straight away with the isolation approach. And the isolation approach is basically the most natural progression that you can think of. When you just test the server, you code the server, you test the client, you code the client, And you don't really think about this kind of chain integration test, like a good integration test, how it's going to look like from this third-party app to the server. You're just like, well, dang, I'm going to start coding. So you do that, and in the server, you'll end up with code that looks like this, right? The server is going to have, this is going to be the post endpoint, right? And you're going to create the song, you're going to store it in the database, and then you're going to tell the user through some JSON output blob, you started okay, right? And this is really simplified. There's obviously going to be more logic there and stuff, but this is the idea, right? And the get method is going to be pretty similar to this, where we're going to look the song up in the database. We'll render back the words as JSON, send it back over the wire, and the client gets that, right? And the server test is going to be somewhat similar to this, where we're just going to use some kind of unit test browser, and we'll make sure that if we post the specific word with specific words, a specific song with specific words, and we get it, then we make sure that the words that we get back, in JSON is what we expect, right? So the server is done, and then the client will have something like this, where we have this getSong method that's going to accept the JSON. It's going to parse the JSON and return the words hash back, right? And then we'll get the words that we did for that song. And the test will look like this, pretty similar, right? We're asserting that we post the song to, we instantiate a new client object. We post the song, we call the method with the name and the words, and we make sure that if we get it back, we get the words back, right? It's pretty straightforward, pretty simple. But this is the problem with this approach, is that in order to test in the client, we're going to actually have to we're going to mock out the server, right? We're going to use something like fake web or webmock or something like that. And that's not necessarily a problem, but when you're mocking out the server, the problem with any type of mocking really is that you're not testing the whole thing, right? And so, for example, if the server changes, if the server guy decides to add a new endpoint or change the parameters that you need to do to post a song or something like that, then the client tests, when they run, are still going to pass because it's not actually talking to the real server, right? And this is a problem because if the server guy changes something and we ship the client, the client guy ships it, the musician guy picks up the client, he starts coding, uses it, and then they find out that their app is broken. He calls up, starts yelling at the client guy, and the client guy's like, I'm sorry, I don't know. I mean, the test passed. So the evolution of our company has to say, okay, well, we can't use webmock, or I mean, there's obviously disadvantages for this. So let's actually run the code against a sandbox, right? Let's put the server somewhere, and we're going to run this client against the real server code, right? And so we're going to put the server somewhere on the internet. It could even be localhost, but the idea is that we're going to run it against the real code. In this example, I say, okay, we're going to put it on sandbox.mymusiclabel.com, right? And the server development is still the same. Nothing really changes there because we're just putting the server there, right? And what's interesting in this approach is that we're going to test the client against the real server code. And so in this case, our client tests are basically going to use that sandbox wherever it's lying, right? And it's going to make real requests, and when we post a song, we're making the same assertion, but it's actually talking to the real server. So if the real server changes, then the client tests are going to fail, right? And that's good. That's what we want. The problem is that setting up sandboxes can take time, right? And things like Heroku and EngineYard and other platforms as services and things like that help you to set up the sandbox, but it's still something that you need to take care of, right? And also, if you're in early stages of development, you always have to make sure that when you develop the client, you're developing against the latest branch, the head of the server that you're developing. And if you always have to do new releases, it hinders your development, right? But what's even worse is that you're making real requests. And if you compare this to webmock, or if you compare this to any type of mocking, fake web or whatever, you're making real requests. You're traversing the whole stack, which is great because that's what you want to do, right? You want to do a full kind of chain of testing, but you're making real requests, and so it's magnitudes of times slower. There's a project that we were working on at EngineYard that took in mocked mode, or this mock setup, it would take maybe a minute and a half, but if you're running it against the real server, it could take 15 minutes. Actually, a recent project is against a partner that we don't really have control over the sandbox, and it takes an hour and a half, right, to run all the tests. I mean, this is a big problem. It's not a small problem, right? It can be a huge time sink. But what's even worse is that you can run into unique data conflicts, right? Like, what happens if you're developing the client, and we were saying that we have a name should be unique, right? You run the test once, it creates a song, and then you run the test a second time, and it can't create it because there's a server-side validation that says this song already exists, and so the client tests fail even though you haven't really done anything, right? Like, it should pass, right? And this issue kind of stems out of the fact that you don't really have control over the state of the sandbox. I mean, you could, in theory, drop the database and restart and run it again, but you can't really control what's happening during the state. So the setup and teardown methods that you do are going to also require time, but also could be impossible, because what happens if you don't have a full featured set API, right? Like, what if you don't have any deletes? You only have writes, right? It's a problem, right? And so, this is obviously not making these guys happy, right? Because they're running into all these different conflicts. They thought they solved the problem of, we're just going to put a sandbox, we're going to run it against the real thing, and it works, right? But it's obviously not a great solution. Or at least there's certain problems they run into, right? And to touch back on our third point beforehand is that there's no real mocking system that we can use in the client, right? And so in theory, if this musician guy needs to develop with that client in his own third-party app, he's going to run into the same issues that we have in the sandbox mode. Or he'll decide to mock it out, which is probably what he should do, but then he's going to run into the same issue that his tests are going to pass if we change our server, right? Which is the same exact problem that we had earlier. But it is worth noting that this is not bad. This is better. This is one step up over kind of this isolated approach, right? Because we are actually talking to the real server, and more so, sometimes you're going to be stuck in this mode, right? Like if you're developing against a partner, which is what I had mentioned, we were stuck in this project earlier. You don't really have much of a choice, right? You don't have access to the sandbox. You're told develop a client against a sandbox, and this is it, right? And there is something good about it, right? Like you are actually talking to the real code, and you're making sure that it's doing the right thing, right? So I just want to note that we're going in the right direction, right? But we could do better. So what about fake servers? So the reason I use this logo is, I don't know how to pronounce it, but I think it's called Lacoste, and it's like a clothing company. And that's the difference between the clothing companies. One's fake, one's real. That's what I found on Google. So the fake server approach is basically we have a server and we have our client repository. And what's interesting to note here is that we're going to have this fake server in the client. We're going to ship it in the client. And you don't have to look at everything. The idea here is that our Rails app API is going to be big, right? It has lots of logic. It has background jobs it's spawning. It has analytics it's doing. It's talking to some external service. It's doing a bunch of stuff, right? But we want our fake server to mimic just what it's doing, right? We want it to be a mirror of the API from the outside. We don't care about all the internal stuff. We care that this API behaves like the real API, at least from the outside. It's like a little mirror. It looks the same. It quacks the same. All that, right? So the idea is that in this kind of example, our fake server would look like this, where we would basically have this hash, right? And we would store, that would be our database, right? We have it in memory. It's super quick. And we render the same type of JSON, right? We'll store the song in that in-memory hash, and when they send a song over, we'll send it back a status OK, and if they want to get the song back, they'll pass the title. We'll kind of look up that key in the hash and send it back, right? And this is doing exactly what our API needs to be doing. And in reality, you could probably do this with a lot more complicated examples. But the idea still holds, is that you want this to mimic the API. You want it to be fast. You don't want to put a lot of effort into it. The idea is that it behaves like the real API. You don't have to build an entirely new server, right? This is just something that's fast in memory, low dependencies. Sinatra is great for this. And then this is probably one of the more important slides, I think, that I would like you to kind of grasp, is that in this mode, what we do is, because we have this in-memory representation of the API, we're going to run all of our tests against it when we develop locally. We're going to develop the client, and we're going to say, yeah, run it against this API, blah, 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 blah. And then when we push it to the CI server, we're going to use some environment variable that says, oh, you're in real mode. Run it against the sandbox, right? Run it against the real server code and make sure that everything that you're doing is actually happening like you want it to happen, right? And the beauty about this is that what ends up happening, so yeah, we'll choose to do it either against the real server or the fake server, right? And the beauty about this is that by doing this and by having our client tests pass in both modes, whether it's real or fake, you're also validating that the fake server that you created that mimics the API actually does behave like the API, right? You're not just validating your client test, you're validating your API that you built, right? And that's actually pretty amazing because it's full integration when you run against this fake thing, right? By doing this twice, you're validating that the fake and the real are actually the same from the outside, from the client perspective or from the third-party perspective. And if you run against this fake representation, it's actually real as far as you're concerned, right? Because it's behaving exactly like the real thing. But it's all in memory, it's all super quick, and it's pretty simple, right? And you could ship it with the client, and you can use it as a mocked mode, right? And so a consumer application can take that and say, okay, I'm going to use it in my, my musician kind of application that's going to post a song to this music labeling company, and it's going to use the client in their code, and it's going to say post song, right? And they're going to post a funky James Brown, whatever, and then they're going to do client.mock, right? Like we do in Fog or Zendesk, if anyone has used it. And then we'll visit that, we'll visit this third-party app, whatever. We'll write a song, upload the song, and what's happening here is that it's actually using that hash, that in-memory hash in the fake server. Right? This is all happening against our fake representation of the API, but it's happening in memory, and from this third-party perspective that is using the client, it's just working, and they don't actually make any real requests. It's working quickly, and it's actually validated to be our real API. We know that this is exactly like our real API because we ran it twice, the company. So this guy's obviously happy because everything's working really quickly, and they're pretty confident that what they have in their code, their tests, are actually valid, right? And that's cool. So I want to give a small side note about Cistern. Cistern is actually a client API framework that someone at EngineYard created not too long ago, which extracts all of the client framework that Fog has and enables you to actually hard code the mocked responses of your API in this client. So you basically build a client and you say, oh, this is the request I'm going to make. These are different models that I have in the client. And then you can actually say, oh, the server is going to respond to me with this request in this way, right, with this mocked response. And so this is basically kind of retracting along the lines that you can actually be in sandbox mode and have some kind of a mocked mode thing if you use something like Cistern. And what's cool about this is that you can actually use the same idea by running it twice, right, and validating that the mocks that you kind of hard code in are actually valid, right? And so I'm going to put this in my resources at the end, and you'll be able to check that out if you want to. So back to the story. The server developer guy is pretty content, pretty happy. He's always happy, actually, because he has the least amount of work to do. But there are more steps in the client because we need to make sure that we're maintaining the fake application, right? We have to make sure that that fake application is like our real server. And in practice, this isn't something that's too hard because we're running it twice. We know that if we change anything in the server, we're gonna, our tests are gonna pass locally, but they'll fail on the CI or something like that, right? Or actually the opposite. But So we'll immediately get this notification like, oh, you need to add this API endpoint, or the parameters are wrong, or something like that. And so in reality, it's not a big deal, but it does make the client library developer work a little bit more. And as you've noticed, I mean, I think a big majority of this talk kind of focuses on the client library perspective, because that's really where you're testing the API, right? Like that's how you're actually interacting with the API. So it's an important note as well. So this picture is maybe a little contrived and weird, but what it's trying to portray is to say, okay, well, what if we share more code and we make the fake and the real repository, we make that fake API and the real API one. We try to make it more dry. And instead, what we'll do is we'll just map out the implementation of whether we're in fake mode or in real mode. So just a quick caveat about this is that I have not seen this approach done anywhere else but EngineYard. And it does require specific libraries, namely some that will allow you to route certain requests into a rack builder so that you can actually, basically, in your tests, run against an application, right? You can actually say, oh, in this mode, I'm going to run the requests against this rack application, but otherwise, just use the internet or something like that. And so let me just get to it, right? So we're going to create a repository to hold the post and get definitions, and we're only going to do it in one place, right? And we're going to also create the client interface and this fake mapper. And the idea of a mapper is essentially that module that's going to say, oh, we're in fake mode or in real mode, and we're going to either have all this fake logic or we're going to have the real logic, and we're going to mount this API with that module inside of it, right? And so that one repository is going to look like this, where we're going to have all our get and post definitions of the API. Again, it's probably going to be something like Sinatra. And the idea here is that we're going to have this get song. That's the API endpoint that we're going to do, right? But we're going to run it on this module called server.mapper in this case, right? And that module is going to say, are we in real mode or are we in fake mode, right? So in our real mode, we're going to put this module somewhere in lib or whatever, where we're going to have access to all of our internal models and whatever we need to have, right? And we can make sure that we have all the server-side limitations, that we can do all our background jobs, all our analytics, anything we need to do, right? And this fake mapper is basically, as you can see, pretty similar to the fake app, right? We have that in-memory hash, and we have that post-song and get-song method and things like that. And what we get to do with Rack, which is really cool, is that you can mount Rack applications on top of each other, right? And so what we do is we just assign the implementation that we want, and we mount that API. So if we want to have the server done with the real server API code, we can basically say server.mapper equals that real implementation with all the background jobs and whatever. And then we mount it at wherever we want to mount it in our Rails app, and we're done, right? Like the server is done, the client can talk to the API like it was doing beforehand, and that's really pretty much it. And the consumer applications can use the fake mapper just like it was using that fake app, right? Where basically we would assign that fake mapper and run it, and then this is again something related to that Rack builder, where you can, in your tests, they could run whatever requests go to us into that fake API, and then anything else would probably hit the internet because you don't want to interfere with them. And so you do client.mock, and this is the same exact idea as that fake API, right? Same idea. So yeah, that guy's happy too, right? So we still have full integration, and this approach is a little bit more dry, right? Because we only have API definitions in one point. We don't have to maintain two separate APIs. Like I said, some problems with this is that specific library dependencies, specifically Rack Client and Faraday. Has anyone here used Rack Client? I'm kind of curious. Anyone use Faraday? Okay. So Rack Client is actually what we use at Engine Yard. It's pretty similar to Faraday, except it uses Racklint, and it's all Rack compliant and stuff. But both of them are very similar in what they do, and so you have to use these libraries. But you also have to kind of be familiar with this. I remember when I started at Engine Yard and saw this, it was kind of convoluted. I didn't really understand what was going on because you look for an API and it's not in your main Rails app, right? But I've also heard a lot of people say that they build their APIs, they will always mount Sinatra in Rails to do that, and it's a pretty good idea, I think, because you get to have this abstraction of your API, and this chunk that is your API, and you can deal with it on the side and do whatever you want, and it's a separation of concerns that can be very helpful than just kind of mangling it into your app. So this is a tech talk. I had to put a cat in there, so that's the cat. And maybe this is how your brain is kind of responding, because I actually summarized about 4 years of development experience that I've seen at Engine Yard into 23 minutes. So yeah, I'm gonna run through some conclusions, and there'll be time for questions. So yeah, APIs are really the foundation of distributed systems. I'm assuming that's why you guys are all here. I mean, it's really, I think this is what this bubble is about APIs. And so that's why I really like this tweet. I think the link I put on the very beginning, if you wanted to go and favorite or retweet it, it's pretty old, but you could probably still find it. Yeah, testing APIs is an interesting problem. Like you've seen, there's no kind of one golden solution. All of them have trade-offs. And I'd be interested to hear what your approach is, because there are many approaches, and I would be really interested to hear what your struggles have been, and maybe you can teach me something new. I'd be super excited. I'm pretty passionate about this subject because I've experienced a lot of pain in this field as well. Also, you should you shouldn't, but you could consider using the client to test the server. There's definitely benefits of doing that because the client is really, in actuality, the client is testing the server, if you think about it, right? And having that, like, it's quote-unquote coupleness between the two actually, to some extent, makes sense, right? A little bit. But if there's one thing I could really hope that you guys take from this talk is that having validated mocks is really useful, right? It's really useful for developing your server locally, and it's also really useful for developing, in a third-party app using that client, right? Because you can use those mocks with confidence and know that those mocks are doing what they are. And they don't have to be on the HTTP level. They don't have to be on the server level. They could be, fake web. It could be like in Cistern where you're mocking out the response. It could be like in the mapper pattern where you're going through HTTP, but you're hitting it on the server level. But the idea is still having some valid representation of the API that's fake and fast is really good. So there are fully tested and working examples of all the different approaches that I've mentioned, and I'll tweet about it. When I'm done, I'll tweet the slides, or actually it's a GitHub repository, so you could just look at it. And I would like to say a quick thanks to Jacob, who's Beanstalk Surf, Jacob Burkhart. He and I worked together on the add-on program. He was kind of leading that up, and I was working with him, and much of this talk came out through the work on that. And he's a great guy, and you should check out his talks. Rat Client, Faraday are two gems that I mentioned that are kind of prerequisites for even looking at this mapper pattern. Fake Web, Real Web, Sinatra Cistern, some gems I'd mentioned. Josh has created recently Cistern, which is something that's worth taking a look at if you're interested. Andy used to work at Engineered, and he has a talk called Toggable Mocks that actually is very similar to this talk. It focuses a little bit more on the idea of having this like mocking system like Fog and Zendesk too. And last but not least, it's a really funny photo of my coworker. So yeah, that's it. So.